This session is about addition and subtraction of rational expressions. I'm going to take you back to addition and subtraction of fractions and remind you that if the two fractions are not alike, you have to make, if the two denominators are not the same, you have to make them the same to be able to add and subtract. So I have denominators that are different, 5 and 15. And what we have done in the past, we said, oh, 5 and 15, the LCD, the least common denominator, is 15. Why is that? Because when we find the common denominator, we have to take all the different factors from both of them. So if you think of 5 as a factor, 15 has 3 times 5 as a factor. Remember, to find the LCD, you have to take every factor the most number of times it's repeated. The number 5 is repeated once, and the factor 5 here is repeated once. So we have to take 5. And then I have a 3, so we have to take the 3. That makes the LCD is 15. Always remember, the LCD should contain both denominators as factors, should contain both denominators as factors, and should be the smallest number that's divisible by both 5 and 15. So I rewrite each fraction with the LCD. So how do I do it here? I know my LCD is 15, and so I want to make both fractions 15. So I look at the 3/5 and I say, well, if I multiply the denominator by 3, I get 15. But whatever I do to the denominator, I must do to the numerator, because I'm looking at a factor of 1. A factor of 1, when you multiply 1 by any fraction, it's not going to change. So 3 over 3 is a 1, and so I still have an equivalent fraction, which is 3/5, because I could always reduce the 3 and the 3 if I want to. So this takes me to the next step. This fraction now becomes 3 times 3 is 9 over 3 times 5 is 15 plus 2 over 15. I don't need to change anything because my LCD is 15. And my next step would be, since denominators are the same, my common denominator would be 15. And then add the numerators. 9 plus 2 is 11. And so my answer would be 11 over 15. And of course, after that, you want to make sure it's reduced to lowest terms. By 11/15, it's reduced to lowest terms. So let's look at those two rational expressions. And we're subtracting here. Now, I'm going to look at the denominators. Right when I look at them, I know that they're not the same. The denominators are different. And to be able to add and subtract, they must be the same. So my first step to do is find the LCD, find the least common denominator. And to find the LCD, if I have everything factored, all what I need to do is choose all the different factors. Notice that I have 5 and 10. So my LCD would have to include 10, because 5 is included in 10 as a factor, and 10 is the largest one, so I take 10. And then I have a squared and a, but notice that the LCD has to contain both denominators, so it has to contain a squared. So I take the one with the higher exponent in my LCD, so I have to take a squared. And then I have b in both of them, so I have to have b in my LCD. So if both denominators are factored, you're just going to look at the constants and just do the LCD like you did before. And remember that the LCD should contain the higher one that's divisible by all of them. So when I look at 10a squared b, I know that this is divisible by 5a squared b, and it's divisible by 10ab. So that's my LCD. So now I need to rewrite each fraction as an equivalent fraction with the LCD. So I'm going to take the 6 over 5a squared b, and I need to change the denominator to the LCD to be 10a squared b. So what is missing here? What do I need to multiply the 5a squared b by to get 10a squared b? The 5, I need to multiply it by 2. The a squared, I already have it. So I don't need a squared, and the b, I already have it. So basically what I need to do to get the LCD is multiply top and bottom by 2. And remember, this is just like the number 1, because 2 over 2 reduces to 1. And so this is going to give me 2 times 6 is 12 over the LCD, which is 2 times 5a squared b is 10a squared b. So I took the first fraction, multiplied top and bottom by the number 2 to get the LCD, which is 10a squared b. And now I need to do the same thing for the second fraction. So I put a minus, and my second fraction is 1 over 10ab. But notice that I'm missing, I need to go from 10ab to 10a squared b. So I'm missing an a here. So I need to multiply by a to get this to be a squared. So I multiply top and bottom by a. And a over a is just like a 1. So I go back here and say, now I have 1 times a is a over 10ab times a is 10a squared b. So I changed each fraction to an equivalent fraction with the LCD. Notice that if you reduce this, divide top and bottom by 2, you got this back. If you divide top and bottom by a, you got this back. So the fractions are still equivalent, but we made the same denominator so we can subtract. So now I'm ready to subtract. My common denominator is 10a squared b. And then 12 minus a would be the numerator. And if you look at 12 minus a, you can't really factor it. And you can't reduce unless you have it factored with whatever is on the bottom. So that would be your final reduced answer. I'm subtracting 2 fractions, so I'm looking at the denominators, and I see that they are not the same. I want to make them the same, so I need to find the LCD. But I can't find the LCD unless I have denominators factored. So my first step would be factor denominators. So leave the numerators the way they are. Here I see 5 is a common factor, so I pull that out. Minus. Here, y plus 2 over y minus 5, can't do anything with it. The y minus 5 is already factored. Now my LCD, remember, it has to contain every different factor. It has to contain the 5. This one doesn't have the 5, so my LCD will have the 5. My LCD should have the y minus 5. So you have to choose every different factor in each one of them. So 5 times y minus 5 would be my LCD. My goal is to change this fraction to an equivalent fraction with the LCD. So my first thing to do is rewrite the LCD, because that's what I want in my new fractions, and then rewrite this as an equivalent fraction with the LCD. So think of what do you want to multiply top and bottom by to get the LCD. So here, 5, y minus 5, I have it, the same thing, so I don't really need to do anything. I'll just bring down my numerator, 6y plus 5. Now here, I have y minus 5, but I need 5 times y minus 5. So what's missing here is 5. So I multiply top and bottom by 5. And so that gives me 5 times the quantity, y plus 5. So this is the same as if you want to multiply, you really have to distribute. So you need to multiply the 5 times y and the 5 times 2. So that will give you 5 times y is 5y plus 5 times 2 is 10. So that would be your next step. Now, after this, once you made denominators the same, you basically subtract the numerators. So your denominator is the LCD, which is 5 times y minus 5. And the numerator is 6y plus 5. So you're going to take the first numerator, subtract. I want to really highlight this subtraction sign, and subtract 5y plus 10, the quantity 5y plus 10. Notice that when you subtract, this negative sign belongs to every term in the new numerator. So my next step, and sometimes I see students go minus 5y plus 10. So they just apply the negative sign to the first term rather than both of them, but you need to apply this negative sign applies to every single term in the next numerator. So that would be, I'll take that here, and I just need to simplify it. So I have 6y plus 5, and here just like I'm distributing a negative 1, so negative 1 times 5y is negative 5y. And negative 1 times 10 is negative 10 over the LCD is 5 times y minus 5. And I'm going to simplify the numerator. Notice that 6y and negative 5y are like terms. 6y minus 5y is y. And then positive 5 and negative 10 are alike, so I combine like terms. And so that will give me negative 5 on top over 5 times y minus 5. And I have to check and see if I can reduce. I see that I have y minus 5 on top, y minus 5 on the bottom. There it goes to 1, so I reduce that to 1. So I have 1 on top, 5 on the bottom, and that makes my simplified answer 1/5. All right, I'm going to take another example. Now, if you look at the denominators, you see that they're not the same, but hopefully you recognize that they are opposites. And because they're opposites, we can change one of them to make it look like the other one by producing a negative sign. That's all. So what I usually do when I recognize I have opposites, because that's quite easy to do, once you look at, I usually take the second fraction because I see that the sign, this sign is going to change. That's all. When I make the second denominator look like the first. You could make the first denominator look like the second the same way, but your sign change would go here. So if I take c minus 7, I know I can write it as negative 7 minus c. Notice when you distribute that negative 1, you're going to get negative 7 plus c. And let's see here. 7 minus c, and that's what I want. So I want 7 minus c instead of c minus 7. So I'm going to go back here and rewrite c over 7 minus c plus 2c over negative 7 minus c. So I'm replacing c minus 7 with negative 7 minus c. Notice for any fraction, if you have a negative sign on top or the bottom, it applies for the whole fraction. So I can always take this negative sign and put it on top if I want to. And so and then this negative sign could apply for the whole fraction, but having a positive and a negative signs together is going to change it to a negative sign. So my next step to do, once I produce that negative sign, see changing the opposite to look like it's changing a number to look like its opposite is going to produce a negative sign. This negative sign is going to change the sign in the middle. So I could rewrite this as c over 7 minus c, a positive and a negative is going to give you a negative, and then I have 2c over 7 minus c. So by doing this, you got denominators to be the same. It's really easy to do them the same if you have opposites down there. So basically, change one denominator factor negative 1 out of it. This negative 1 is going to change your sign here. If it's positive, becomes negative. If it's negative, becomes positive, because two negative signs will give you a positive. And then denominators are the same. So I take the common denominator, which is 7 minus c, and subtract the numerator, so it's c minus 2c. And c minus t is negative 1c, or just negative c over 7 minus c. And that would be my final answer for this one. So this is a case dealing with adding or subtracting when you're dealing with opposites. All right, so here I'm subtracting the first two fractions and then adding the third one. So I look at the denominators, first of all, and I see that they're not the same. I need to find the LCD, but to find the LCD, I must factor. So I'm going to take the 2x over x squared minus y squared factors to x minus y times x plus y, minus 1 over x minus y does not factor, and then plus 1 over y minus x. I see that it's the opposite of x minus y. Hopefully you recognize that. So what I do is change it to negative x minus y. So I change the y minus x to negative x minus y. And notice that those two signs, a positive and a negative, is going to give you a negative right here. So I'm going to go back and rewrite them with the correct signs here. So my first fraction is 2x over x minus y times x plus y, minus my second fraction is 1 over x minus y. And then here, this sign has changed to minus 1 over x minus y. Now I need to make denominators the same. If you want, since you see this and this, they have the same denominator, you probably could combine them together if you want. Or I think I'm going to just use the long method and change all of them to have the same denominator, because you're not going to always have a special case like this. So x minus y times x plus y is one denominator. X minus y is another one. And so the LCD has to contain every single denominator. So it has to contain that. So my LCD has to have x minus y times x plus y. And notice that this contains the x minus y, this denominator, so it's right here, and it contains this one. So that's my LCD minus. So I'm going to put the LCD for all of them, because all of them should have the same denominator, minus x minus y times x plus y. Okay, so this fraction contains the LCD, so there's nothing to do. I just bring it down the way it is. This fraction has x minus y, but the LCD contains x minus y times x plus y. So I must multiply top and bottom by what's missing, which is x plus y. So I multiply top and bottom by x plus y. And when I do that, I distribute this one over. So I get x plus y. And here, I still need to multiply top and bottom by x plus y to get the LCD. And again, I distribute that one over. So I get x plus y. And all what I need to do is keep my LCD the same and subtract the numerators. So let me take this up here, just erase my original problem here and do that step up there. Okay, so my LCD is x minus y times x plus y. And then subtract the numerator, so I have 2x minus x plus y. See where that negative sign goes in front of the parentheses, and then minus x plus y again. And now I need to simplify the numerator by distributing that negative 1, the negative sign just like negative 1 right there, distribute right here. So you have 2x minus x minus y minus x minus y, again here, over x minus y times x plus y. And that's going to be combined like terms, 2x minus x minus x. Well, 2x minus x is 1x, x minus x is 0, so that's a 0 right there. They cancel out. And then negative y and negative y is going to give you negative 2y over x minus y times x plus y. And this is simplified because the top is factored, the bottom is factored, and I don't have any factors that are the same. Subtracting two rational expressions. First step is to factor each denominator so you can find the LCD. So 2 over. Let's see, is there a common factor? I have 4, 12, and 9. There's no common factor. Let's see how we can factor it. Looks like it could be a perfect square trinomial. So I would probably go with 2z times 2z for the 4z squared, and the 9 is 3 times 3, and make both of them negative. So inside will be negative 6z, outside will be negative 6z, so that's the correct factorization. And the second one, I have z plus 1, and here I pull a z out, so I have 2z minus 3. So that's how I factor it. I have a common factor. Now I'm going to look at both denominators and find out what the LCD is. Okay, and sometimes I can like build my LCD. I say, well, the LCD has to contain this denominator, has to contain both of them. So I take the first one, so I take the 2z minus 3 times 2z minus 3, simply because my LCD has to contain that. And it has to contain this, so you think, what do I have here that I don't have in my LCD? 2z minus 3, I already have it. The z I don't have. So this has to have a z. So that's my LCD. Has to have a z, has to have 2z minus 3, 2z minus 3. And then if you look at that, it contains the first denominator, there it is, and it contains the second, there it is. So it has to contain both. Minus. So let me write the LCD again, which is z times 2z minus 3 times 2z minus 3. Now, how do I go from here to here? So I look at my denominator and say, well, what is missing here? Do I have the LCD? And you will probably notice that this doesn't have that z. So you need to multiply top and bottom by z. And when you do that, then you go 2 times z is 2z. And the denominator is what you got, the LCD. Now here, what's missing? The z, I have it. 2z minus 3, I have one of them, but I don't have the other one. So I need to multiply top and bottom by 2z minus 3. And my next step here is to FOIL, multiply z plus 1 times 2z minus 3. So I need to FOIL right here. And you could do this on scratch paper, however you want. But I'm going to do it my way here quickly. Z times 2z is 2z squared. And then my outside z times negative 3 is negative 3z. And inside 1 times 2z is 2z. So I have negative 3z plus 2z is negative 1z. So it's negative z. And then last times last, 1 times negative 3 is negative 3. So I'm done with that. My next step is to subtract, putting everything over the common denominator, which is z times 2z minus 3 times 2z minus 3. And so to subtract, so I have 2z, and I'm subtracting this whole numerator. So notice that when you subtract this whole thing, you can distribute that sign. So I'm kind of going quicker here. You could have write this down and then distribute, but you could also distribute here and put it down there. So it's minus 2z squared plus z plus 3. Notice that this negative sign is going to change all the signs after that. Let's combine like terms. I have negative 2z squared right there. So I'm kind of starting with the highest exponent term. And then I have 2z and plus 1z is plus 3z. And then I have a plus 3 over the LCD, which is z times 2z minus 3 times 2z minus 3. Let's see, can we factor? So the last thing to do is to see if you can factor the top and if you can reduce. But you know what, I think, okay, if you want to factor, you need to pull negative 1 out, so you can factor that trinomial. I don't think it factors. But if you pull negative 1 out, then you have 2z squared minus 3z minus 3 over the LCD. And then see if this factors. Well, I don't think it factors because remember the rules. If you multiply 2 times negative 3, which is negative 6, do we have factors of negative 6? They add up to negative 3. They don't. So like basic rules of factoring trinomials is not going to work. So I know I'm not going to be able to factor this, so I'm not going to be able to reduce it. So you need to try to factor it. And if you can't, you just say, well, this is your answer. So that's your simplified answer.